5-6 inequalities in one triangle. So our objective, to use inequalities involving angles and sides of triangles. All right, let's get started. There's no new vocab for this lesson. So let's just dive straight into it. All right, so you have your comparison property of inequality. All right, so you're probably going to look at this and go, really? You had to tell me that? Yeah, I'm telling you this. So if A equals B plus C, and C is greater than 0, then A is going to be greater than B. What does that mean with numbers? If, say, A is 5, and C is greater than 0, so C is, say, 2, right? That means that B has to be 3 in order for B plus C to equal A. Okay? Let me write that down. Okay? Where's my... There it is. All right? If A is, say, 5, and that equals B plus 2, all right? A will have to be greater than B in order for B plus something to equal A. Okay? All right. So that's all that says. If A equals B plus C and C is greater than 0, then A is going to have to be greater than B. All right? So now we have our corollary to our triangle exterior angle theorem. If you remember, angle 1 equals the sum of 2 and 3, which are the remote interior angles. Okay? Because of that, since angle 1 is an exterior angle, that means angle 1 is larger than both angle 2 and angle 3. Okay? Angle 1 will always be larger than 2 or 3. All right? Because remember, 1 equals 2 plus 3. So you add these together, you get 1. So 1 is larger than 2 or 3. Okay? That's your corollary. That's all it says. So let's apply that corollary, and then let's test to see if you understand why. All right? So here we have a triangle. Well, if you look, we have triangle ACD, but we also have triangle ABD and CBD. Okay? So in triangle ACD, CB is congruent to CD. So that makes this triangle CBD, that makes it an isosceles triangle. Since this is an isosceles triangle, we know the two base angles are the same. So we know 1 is congruent to 2. Okay? We know 1 is congruent to 2. Now, since angle 1 is an exterior angle of triangle ABD, okay, that means that angle 1 here will have to be larger than 3. Okay? And we're trying to prove that we're trying to figure out why 2 is greater than 3. Okay? Since 1 is an exterior angle, we know it has to be greater than angle 3 because 3 and 4 are the remote interior angles to 1. So 1 is larger than both of these angles. Okay? Well, since we know that 1 and 2 have the same measure, we can use substitution to say 2 is greater than 3. Whoops, that's supposed to be an underline. All right? We can use substitution to say 2 is greater than angle 3. Okay? Because, again, 1 is an exterior angle of triangle ABD, so that means 1 is greater than 3, and by substitution, 2 is also greater than 3. Okay? So, I want you to tell me why angle 5 is greater than the measure of angle C. Okay? Why the measure of angle 5 is greater than the measure of angle C. Alrighty. Hopefully you said that angle 5 is greater because angle 5 is an exterior angle. So, by the corollary to the triangle exterior angle theorem, angle 5 has to be greater than angle C. Okay, so why is it greater? Oops. It is greater because of the corollary to the triangle exterior angle theorem. A lot of abbreviation there. Okay, so we know this is an exterior angle. This is one of the remote interior angles. So by the corollary to the triangle exterior angle theorem, it says that 5 will have to be larger than the measure of angle C. All right, that's all that says. Pretty simple. Exterior angles are larger than the remote interior angles. Okay, here's two more theorems. I'm basically going to talk about these at the same time. Okay, it says if two sides of a triangle are not congruent, then the larger angle lies opposite the larger side. Then if two angles are not congruent, then the longer side lies opposite the larger angle. All right, so anytime you have a triangle, all right, anytime you have a triangle, the largest side is always opposite the largest angle. Um, that's what the 511 says. Anytime you have, okay, a triangle, the longest side is always opposite the largest angle, and vice versa. The largest angle is always opposite the longest side, and the smallest angle is always opposite the smallest side, and vice versa. Okay, and then of course the um, the medium side is always opposite the medium angle, basically. Okay, so largest side opposite largest angle, smallest side opposite smallest angle. All right, that's basically what these two theorems say, and that always, always, always is the case. Longest side opposite longest angle, smallest side opposite smallest angle. It's always going to work that way. It's never going to change. Okay. So let's look at a problem here. It says a town park is triangular. A landscape architect wants to place a bench at the corner with the largest angle. Which two streets form the corner with the largest angle? Well, if you remember from the last slide, the largest angle is always opposite the longest side. Which one of these is the longest side? Hollingsworth Road. So that means the angle opposite the Hollingsworth Road will be our largest angle. Okay, so MLK Boulevard and Valley Road form the largest angle. So this is where he's going to put his bench. Okay, right here. Now let's see how well you understand this. Suppose the same landscaped architect wants to place a drinking fountain at the corner with the second largest angle. Which two streets form the corner with the second largest angle? Take a few minutes to figure this out. All right. If you remember, the largest side opposite the largest angle, smallest side opposite the smallest angle. So, and the medium side is opposite the medium angle. So he wants the second largest angle. Well, this is the second largest side here, Valley Road. So it's going to be opposite of Valley Road. So our drinking fountain is going to go on the corner of Hollingsworth Road and MLK Boulevard. This is the second largest angle. Okay, that is your second largest angle. Okay, now this might look a little confusing, but I'm going to clear it up. It says for three segments to form a triangle, their lengths must be related in a certain way. Notice that only one of the sets of segments can form a triangle. The sum of the two smallest lengths must be greater than the greatest length. Okay? All that means is this. If you're given a triangle, if you're given three numbers and asked, can this make a triangle? Find the two smallest ones, add them together. If they're greater than the largest number of the three, it'll work. If it's the same or smaller, It won't work. That's basically what this whole thing says. What do I mean by that? Well, if you look at here, say I said we have 3 sticks. 2 of them are 3 centimeters long, one of them's 5 centimeters long. Will these 3 sticks be able to form a triangle? All right, so what you do is you look for the 2 shortest sticks. In this case, they're 3 centimeters each. Add them together. 3 plus 3. That equals 6. Okay, so then you want to look, is 6 greater than the other side, 5? Is 6 greater than 5? Yes, it works. So 3, 3, and 5 will, in fact, make a triangle. Okay? Now, what about this one? You have two 2 centimeter sticks and a 6 centimeter stick. Will that make a triangle? No, because 2 plus 2 equals 4, and 4 is not greater than 6. So this will not work. Okay? So if you're given 3 lengths and ask, will this make a triangle? Take the 2 smallest, add them together. It has to be greater. Okay. What about if I gave you 3 sticks that were 3, 7, and 10? Would these make a triangle? Well, let's do what we just did for these two up here. Let's find the 2 smallest. The 2 smallest are 3 and 7. 3 plus 7 is 10. Is 10 greater than 10? No, 10 is not greater than 10. 10 is equal to 10. So therefore, this will not make a triangle. All right, this will not make a triangle because if you had a line with a length of 10 and you put a line above it with a length of 3 and laid one next to it with a length of 7, you would have 2 lines with a length of 10. Okay, they would not make a triangle. You would just have 2 lines the same length. They would not make a triangle. These two need to be greater in order to put any kind of angle between them, which would also put an angle here and here. Okay, if this was changed to 8, all right, 3 and 8 now is 11. Is 11 greater than 10? Yes. So 3 and 8 will make a triangle. 3, 8, and 10 will make a triangle. But 3, 7, and 10 will not. Okay? This is basically what I just said. Can we have a triangle with these 3 lengths? All right, add the 2 smallest together, 3 and 7. That's 10. Is 10 greater than 8? Yes, it works. Okay? You don't really have to do the rest of these. You really don't. Okay, they did it all 3 ways, but you really don't have to. Just find the 2 smallest, add them together, and see if it's greater than the largest. If it is, it'll work. You don't have to do the other 2 ways. Okay? Like here. All right, 5 and 10 are the 2 smallest. 5 and 10, is that greater than 15? No, it equals 15. So this will not make a triangle. Will not make a triangle. All right, let's do this last got it. And I think the next slide contains your taking. No, the next one doesn't. Anyway, just go ahead and do these two and see if you can figure it out. So pause the video, take a few moments, figure it out. All right. So let's see if it works. Take the 2 smallest, 2 and 6. 2 plus 6 equals 8. Is 8 greater than 9? No, so this will not make a triangle. All right, find the 2 smallest, 4, 6, and 9. 4 plus 6 equals 10. Is 10 greater than 9? Yes, so this one will make a triangle. Smiley face. Okay, this one will make a triangle. All right. So now the last thing we're going to go over, it's along the same lines of what we're doing. It says let x represent the length of the third side. Use the triangle inequality theorem to write 3 inequalities, then solve each inequality for x. What does that mean? That means we're given 2 sticks and we have to find possible lengths for the third stick. Okay? We have to find possible lengths for the third stick. So we know one of them is 5, one of them is 8. So we have to set up 3 inequalities to find the possible lengths for the third side. Okay? And then we have to know, so then we're going to find a range that that third side can be. All right? Now, normally I don't do it this way. What I do is this. Okay? I take the two numbers, so we have 8 and 5. Okay? We have 8 and 5. Add them together. 8 plus 5 equals 13. Okay? Now, take them and subtract them apart. 8 minus 5 equals 3. Okay? So, in order for this to make a triangle, okay, with a side of 8, 5, and we have an unknown, add them together. This is the largest, okay? X has to be less than 13, okay? But at the same time, it has to be greater than the difference, okay? So X can be anywhere from 3 to 13. It can't be 3 and it can't be 13, because if that's the case, it wouldn't make a triangle. But it can be anywhere between 3 and 13, okay? So if you're only given two sides, like we were here, one was 8 and one was 5. If we're only given two sides, what you do to find the possible lengths for the last side, add those two together, it has to be less than that. Subtract the two, it has to be greater than that. Okay? And make sure when you subtract them, you don't end up getting a negative number. Like, don't do 5 minus 8 and get negative 3 and say, oh, it has to be greater than negative 3. Well, negative 3 is not even possible. Okay? So add them together, has to be less than that number. Subtract them, it has to be greater than that number. Okay? Try it out. Do number 5. Try it out. Triangle has side lengths 4 and 7. What is the range of the possible lengths for the third side? Knock that out real quick. All right. So let's knock this out. Hopefully you added them. You started by adding them together. 7 plus 4. Well, that's 7 and 4. What is that? 11. And then 7 minus 4. That is 3. So your third side, we'll call it y, so we don't confuse it with this problem. Y will have to be less than 11, but greater than 3. So that is your answer to number 5. It'll have to be greater than 3, but less than 11. Okay? So that's pretty much it for this lesson. Here's your ticket in the door. Make sure you copy down the questions and bring this to school tomorrow. Bring it to class. The answers will be on the board, but make sure you write the questions and try it yourself. Number 1, use triangle ABC for exercises 1 and 2. So we're going to use this triangle right here for 1 and 2. It says, which side is opposite, which side is the longest? Side AB, side BC, or side AC? You got to find which side is the longest. Number 2, which side is the smallest? Okay, so you got to find which side's the smallest. Number 3, can a triangle have sides of lengths 4, 5, and 10? Is that possible to make a triangle? Number 5, a friend tells you that she drew a triangle with a perimeter of 16 and one side length of 8. How do you know she made an error in her drawing? And she did, in fact, make an error in her drawing. And number 5, is it possible to draw a right triangle with an exterior angle measuring 88 degrees? Explain your reasoning. All right, so go ahead and do these 5 problems. Make sure you bring them to class with you tomorrow. Good luck.